Welcome to our video on matrix operations on the graphing calculator, and we're also going to look at some basic applications because we only know a couple basic operations. It'll be tough to really expand upon yet, but I will have you watching a short video explaining how matrices are actually used in the real world to model such things as possibly an outbreak, like we've experienced with the COVID-19 outbreak, pandemic, or how you can edit a picture with a matrix. So when you actually edit or apply filters to a picture, there's some work behind the scenes that's actually using matrices to achieve whatever kind of edit that you prefer. So we'll be taking a look at a short video on that after you're done with this one. So really quickly here, matrices on the graphing calculator. So you, first of all, if you do not have a graphing calculator, there is a great website that you can use that will allow you to do some operations with matrices. I think it's pretty self-explanatory, but we can look at it in class together if you do not have access to a graphing calculator. So on your graphing calculator, the most important thing to remember is that your matrix menu is going to be found by pressing the second key, and then you see matrix right above the X to the -1 key. Once you're in the menu, you can actually edit your matrix by moving 2 screens over to the right, and then you'll select whatever matrix you would like to edit. Once you're in that edit menu, then you can, first of all, determine, and I can show you more of this in class if you need to, but once you're in the edit menu and you select matrix A, for example, you'll be able to input the dimensions or the order of that matrix and then actually input your matrix right into the calculator. So you'll notice that matrix A for me is a 3x2 matrix because I have 3x2. And what I've done is I've actually put that matrix into my calculator under the edit menu. Now, once you have your matrices entered in the edit menu, then you can do any kind of operations with them. So for instance, I can go back out to my home screen and I can press second matrix or second X to the -1 power. And then to select a matrix that I've already entered, I just stay here in this first menu, which is names. Now let's say I wanted to add A plus B together. I would select matrix A. That's going to put me back on the home screen, and you'll see matrix A on your home screen. You press the plus button, and then you go back into your matrix menu in the names again, and then select matrix B. And when you do that on your home screen, you're going to see this. Now once you press enter, you're going to get a matrix that looks like this, and that's just taking A and adding it to B. So 4 plus 3 is 7, 3 plus 11 is 14, -6 plus 15 is 9, and so on. And you won't have your calculator making silly mistakes like I made in one of our previous videos. So that is just some basics on using the graphing calculator. Go ahead and try entering in your matrices that you see here. So again, you're going to go to your calculator, you're going to press second, and then X to the -1. Second X to the -1, and then you're going to scroll over to edit, select matrix A, so press enter, and then a screen will come up. You're going to have to tell it what the dimensions are, what the order is, and remember this is a 3x2 matrix, so you'll enter 3x2, 3, enter, 2, enter, and then you can just enter each of your elements. So you'll press 4, enter, 3, enter, -6, enter, 1, enter, 10, enter, and then 1, enter. Now, before you go on to enter your next matrix, you'll want to quit. So second and then mode, second quit. That'll put you back on the home screen. And then you start that whole process over again to get matrix B. All right, so enter your 3 matrices and then come on back and we'll try doing some operations with those. All right, hopefully you have entered all of those matrices in your calculator. Now is just an opportunity for you to practice a little bit with the operations. So remember, what you're going to do is you're going to start out by on your home screen, so press second quit no matter where you are, and that'll put you back on your home screen. And we're going to enter the 2 matrices in and add them together. So we're going to practice with A plus B. So you're going to press second X to the -1, stay right there in the names menu, press 1 to select matrix A, puts you back on the home screen. We're going to then say plus, then we go back into the matrix menu. So second, X to the -1. This time we want to press 2 for matrix B, and then just press enter. And you should get that matrix that we saw on the previous screen. So what I'd like you to do is try some of these. First of all, notice something like this means that you do 4 times and then go find matrix A minus matrix B. This is matrix A times, or matrix B times matrix A. It's really important that you do that in the proper order and put a multiplication symbol in between them, all right? If you get something that says error, think about what that means. It probably has to do with the dimensions not being correct. So if you do get something that says error, I want you to write something like undefined, and then give me a quick explanation as to why. So take a few minutes, pause the video here, and try to do these 8 addition, subtraction, multiplication problems, and then come back and check your answers. All right, so take a minute here, check all of your answers. A couple of things I wanted to point out. First of all, if you're not getting the same values I am, go back in and make sure that when you entered the matrices that you did not leave off a negative sign or mistype a number, because that primarily is where you're going to make your mistakes. 2, there's a couple of these that are undefined. B times A can't be done because the number of columns in B is not the same as the number of rows in A. And when we multiply, those two things have to be the same in order to be able to multiply. The last one was undefined. When we try to add or subtract matrices, they always have to have the exact same dimensions, and matrix C has different dimensions than both A and B, so you won't be able to add those together. Notice also that these two are exactly the same. It's essentially saying if we distribute this C times what we see in the parentheses, we'll get this, right? So those two matrices will have the same difference. All right, let's talk about some really basic applications. You can actually put some data in a matrix and organize it nicely that way. So if you have this power tool company, it has 4 plants where it manufactures 3 different types of cordless power tools, and the production levels are represented by matrix A. We can very easily find out what would happen when our production is increased by 20% by just taking our matrix that organizes all of that data and multiplying it by a multiple that will give us an increase of 20%. So what I've done is I've organized it so that my plants are the columns and the type of power tool are the rows. So if I wanted to know how many of type B are being produced in plant 3, I go to my column for plant 3 and I look at, I look at plant or type B, the second row. And I can see that plant 3 is producing 80, right? They're producing the least amount, that's the least amount that they produce of the 3 types at plant 3. So if I wanted to see what would happen if we increase production by 20%, I just have to multiply that matrix A, by some scalar. Now the scalar I'm going to multiply is not 0.2, right? Because that would just give me 20% of each of those numbers. It would have to be 1.2. And once again, that can be done using our graphing calculator if we wanted to enter matrix A into our graphing calculator and then do the multiplication that way. You could do that. You could just multiply every entry by 1.2. You're really kind of free to choose your options there. Go ahead and find out what 1.2 times matrix A is and come back and check your answer. So you should have something that looks like this. So if I asked you, how much is plant 2 producing of type let's say C, you could look at the column that represents plant 2, which is right here, and the row that represents type C, which is right here, and just look at where those two things intersect, and I would see that those are intersecting at 72. So I could say 72, okay? Now, this type of organizational thought is really common. In fact, those of you that are kind of wondering what Mr. Middleman is doing now that he has left us, he's doing this kind of thing. So his work is primarily based on spreadsheets and matrices and that kind of thing. All right, let's go ahead and look at another example. We're going to actually come back to using matrices to determine if a point is collinear, because we need to actually know how to find a determinant. And that's coming up in a video here in the future. So we'll come back to this example in that video. Here's just another example of how we can use matrices to organize data and find some very quick, manipulations of that data. So if we have 3 girls, Alexandra, Megan, and Brittany, and we know some grades, averages for test projects, homework, and quizzes, we can easily calculate their grades using a matrix if we have weighted grades. Now, for most of you, the weighted grades thing is actually something that you experience. So we could use matrices here to help us find their total grades. So in order to do this, we're going to have to actually organize our data in a matrix. Now, you can kind of see it's already sort of done for you, right? This could be considered one matrix, where I see Alexandra's grades across the top row, Megan's grades across the second row, and Brittany's grades across the third row. And then my columns are tests, projects, homework, and quizzes. And then my second matrix would be this matrix, which shows me tests, projects, homework, and quizzes along the each row, which makes sense, right? Because when we multiply a column in the first matrix by a row in the second matrix. So if I were going to multiply these, I would multiply this column by this row to get test averages. And that's why our matrix multiplication is set up that way. Now we're going to do this using a calculator, so we'll set this all up on our calculator and do the multiplication that way. But I want to write out what the matrices are going to look like. So my first matrix will look like this. We're going to have our tests in one column, projects in another column, homework in our third column, and quizzes in the fourth column. And we can see again, oops, that should be 92, not 72. We can see that the grades are, Alexandra's grades are here, Megan's grades are here, Brittany's grades are here. Now we're going to multiply that by our weight matrix. So we're going to do 0.4, 0.15. I need to make my matrix a little bit bigger here. So 0.4, 0.15 for 15% for projects, 0.25 for homework, and 0.2 for quizzes. Now remember, the process is we have to look at the number of rows by columns, so that's 3 by 4, and the number of rows by columns, so that's 4 by 1, and we look at what the inner numbers are, number of rows or columns in the first times the number of rows in the second, has to be the same, and it is. So we know that we can multiply them, and when we do, we know it's going to end up being a 3 by 1 matrix. So the final product will have 3 rows and 1 column. So let's go ahead and figure out what that is. All right, now this is going to give us our final grade for each of the girls. Once again, I want you to use your calculator for this. So go ahead and type in the two matrices into your calculator and find the product. I do not want you to do this by hand, okay? So type it into your calculator, find your product, and come back and check your answer when you're finished. So if I wanted to know what Alexandra's overall grade is, she actually ends up with a 90%. So, whoops, sorry about that. Alexandra ends up with a 90% overall. Megan will end up with about a 77% because we'll round that. And Brittany winds up with an 87%. So we can very quickly calculate grades this way. It's a much quicker way than finding 40% of each of the grades and then finding 15% of each of their project grades and then 25% of each of their homework grades and then 20% of each of their quiz grades and then adding those all together, right? That could take a long time. This, because we can set up a matrix and do some manipulations with the data that way, is a much faster way of finding their grades. And this is actually what Infinite Campus does in the background when it's calculating your grades, especially if there are weighted grades for a class. Okay, there's one other video I'm going to have you watch, and it's not my video. It's one I found on YouTube that I think does a great job of explaining a couple of other real-world applications of matrices. And one of them will be how an outbreak or a pandemic actually is modeled using data. And then another one will be if you've ever done any kind of editing on a picture, how it actually happens with each of the pixels being edited so that the overall picture changes slightly. So watch for that link in your assignments, and when you're done, we'll talk about these in class.